Yeah, okay, good. Yeah, good rectangle. Yeah, it's going to be a little bit of a challenge because we have a lot of boards in this room. I do want to use all of them at some point. So what I'll do is I'll just kind of swing, not today, but I'll swing the arm around. I'll get this dialed in eventually to the point where it actually looks decent and sounds decent. I bought a little mic for it a couple days ago. I forgot to bring it in. So hopefully the sound will get better as we refine it. So I appreciate your patience as we kind of deal with it. But if anything else, it can't be worse than not having it. So if anything, it's going to add a little bit to it. So anyway, welcome. So what today is going to be essentially, every statistics textbook kind of starts the same way. Even this one that we got at a very, very good deal, it's very, very slimmed down. They all kind of start the same way, and they all kind of progress almost the same way. They've got the same kind of sections in them. This is what drives me nuts about textbook manufacturers. They produce the same book every 3 years. They change a couple pictures. They might change some chapter numbers, but it's essentially the same book as it was before. There's nothing cutting edge 3 years later. You're right, exactly, which is why I'm so excited about going open source. But all of them progress in almost the same way. The first chapter or two is a whole bunch of information, a whole bunch of graphs, bivariate, univariate, qualitative, quantitative, a whole bunch of measures, a whole bunch of definitions. And about 70% of it, they say things like, okay, so later on in the course, when we approach blah, 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 make sure you remember how to do blah, blah, blah. To which I've learned over the past 20 years to realize you won't remember that. Hell, I won't remember it, because I don't expect you to. So what I've kind of done is, in this first bit of the course, is I've kind of gone through the textbook and extracted from the first couple 80, 50, 80, 100 pages the stuff that actually is important for right now. Everything else is important. I'm not saying it's not important. I'm saying it's not important at this moment. It'll be important when it's important. For example, they talk about z-scores very early on in the book. A z-score is a wonderful thing. It's how you could compare, for example, Michael Phelps to Mark Spitz, both amazing Olympic swimmers. But it's kind of hard to compare them apples to apples, because Spitz was in 72 and Phelps was relatively recently. Training has changed from 72 to relatively recently, so it's kind of hard to look at time because the times are vastly different. But a z-score gives you a tool to compare them. The problem is, we don't talk about that kind of thing until like week 8 or week 9 in this course. So why learn it now, forget it, and then relearn it in week 8 or week 9? It seems kind of silly. Another example is something called an ogive, which is a funny thing to say. It's an example of what's called a cumulative frequency polygon. Yay, it's a wonderful, wonderful term. It also makes no sense to talk about right now until we understand what a percentile rank is. And understand what a percentile rank is, you have to know what relative position is. And that's like, I don't know, 4 or 5 weeks off. So rather than learn it and then forget it and relearn it, let's just not learn it at all right now and pick it up when we need to. But there are a few things that start from day one. And the most basic part of the course, I just like to call data. Data. And I don't even know that's a good definition of it. I'm going to try to define what data is. Data is something you're interested in. You're interested in data. Give me the example of something you would be interested in to collect data on. Raphael, you gave me a great example earlier.
Let's see, how many animals are homeless?
Oh, that's fantastic. I wasn't thinking of that at all. Number of homeless animals. Feral cats. I was actually helping the Ben Stay and Neuter Project for a while, figure out where the feral cat populations were in Ben, because they should be reproducing. And I heard an amazing statistic. I almost can't believe it's true. Hundreds of millions of songbirds are killed every year by feral cats and outdoor cats. I mean, it's like hundreds of times more than they thought it was. I mean, it's staggering, the number of... So yeah, that would definitely be interesting to whoever, really, for that matter. Good. I was thinking you were going with the wiring the room for camera.
Oh, no.
Like on a scale of 1 to 5, how important would it be for this room to be wired for video recording? Like I'm kind of doing a little bit ghetto-ish up here on the other part of the room. So yeah, with 1 to 5, 1 being I don't care, 5 being yeah, let's do it. And you can ask everybody, and then you can collect that data if you were interested in that. Good. Any other examples you guys think of? I love the feral cat one. That's fantastic. Please tell me your name again. Tabitha, yes.
I want to know scores on like safety tests for cars.
Oh, so when you're shopping for a family car, like a Volvo. I've heard they're very good family cars. Volvos. A lot of buffer zones. Volvo. I've been told they're very safe. Volvos.
Yeah, they are. Yeah.
Swedish. I don't know. I'll stop talking about Volvos now. Sorry. But yeah, exactly. Scores, comparative scores, making sure they're apples to apples, as we mentioned before with Phelps and Spitz. Good. Thank you, Tabitha. What else? Something else you might be interested in.
Calories in food.
Fantastic. I've noticed that some fast food places are now actually putting that in their menus. Like if you want to buy this combo meal, it's going to be this many calories. Yeah, for sure. Food energy. I'd also like to see, and those of you that understand nutrition better than I chime in, I'd also like to see some kind of a calorie measure that gives you like the quality of the calorie. Like I've often heard that alcohol it's 7 calories per gram, I believe, is what alcohol is. That I've seen some nods, right? And like fat is something like 9,
Yeah.
carbs are 5. I'm throwing these numbers out like I understand them.
I think it was 4.
4.
And then protein was like 7 or something.
Protein
like that.
7 and, right. I'd love to see, like, because not every calorie is equal, right? I mean, you know, you've got empty calories like alcohol, and you've got like energy-packed calories like carbs, or like starches like rice or something like brown rice. Love to see that kind of a thing cross-referenced. Great, these are great examples. All kinds of data, all kinds of data. Now what's cool is what you guys mentioned could either be termed in one of 2 ways. And I like the 2 definitions that we're going to use here from the beginning and onward. Qualitative versus quantitative. Qualitative is attribute, characteristics, some kind of characteristic that's not a number. That's not a number. So for example, the type of food we just mentioned, or the type of, I don't know if that food is the right word, is it a carbohydrate? Is it an alcohol? Is it a fat? Is it a protein? Those aren't numbers. They're attributes. They're attributes. Okay? What type of food are you eating? Is it rice? Is it pasta? Is it a meat product? Is it a vegetable product? Not numerical. Raphael, I mentioned one that can kind of be misconstrued as a numerical data when I said, how interested might you be in wiring this room for multimedia? Scale of 1 to 5, 1 being I don't care, 5 being I really care. Well, that really isn't a number. 1 is I really don't care. 2 is I kind of care a little bit. 3 is and 4 is I'm leaning towards caring. And 5 is like, hell yeah, put some wires in this room. So even though there's numbers attached to that, they really aren't numerical data. It still falls into this category of qualitative. Natural resource folks. Any natural resource folks in here? Yeah, you guys are out in the woods collecting all kinds of data about forbs. I'm using a word I don't really understand. A forb is something, right? Like is it a grass?
So the magazine.
Well, it is, but there's also, is it grasses? Is it a bush? Or is it a tree? There's a thing called a forb. I'm trying to sound intelligent. It's not working. Damn it. Stick with math rule. Anyway, the type, ponderosa, juniper, manzanita, those things, they're not numbers. You can code them with numbers, but they're still standing for something that's not a number. Qualitative data is great, and we're going to play with it a little bit today. But there's not a whole lot you can do with it. I mean, you can basically count how many of something that you have. That's essentially, you're limited to basically doing that. And we'll talk about this more later on. It's easy to try to do more to this than you're allowed to do. Like, for example, you guys have done class evals at COCC? You have a scale of 1 to 7, or at least there used to be a scale of 1 to 7.
Not lately.
What's that?
Not lately.
Not lately. Well, it's okay. So 1 strongly disagree, 7 strongly agree, 4 neutral. Like those numbers aren't really numbers. Just like we talked about with Raphael's, you want to wire the room for multimedia. There really are words. So it's really this. So really the best you can do with that data is see how many of each of the responses came in. But oftentimes people try to average it. Like I've often been told, oh look, you have a 6.5 average on shows up on time for class. That means you're doing pretty good. How did you get 6.5? What is 6? Like I'm almost all the way there, but not quite. Like it's not a number, right? It's a word. It's between 6 and 7. So anyway, we'll get back to that. So qualitative is great, except for the fact that we can't do a whole lot with it other than just count. And that's okay. That's okay. That has its place. I'm not saying that's not good. That has its place. Natural resource folks. Which tree is most prevalent? And is it exceptionally prevalent? Is it higher than 20% more prevalent than any other tree? Is it crowding out, say, native species? And this is important. This is important stuff. I'm not trying to trivialize it. It's just you can't do a whole lot with it. Now, when you have quantitative data, though, and just time out, FYI, I'll have this PowerPoint posted for you at the end of the day. So you don't have to scratch all this down if you don't want to. You can just kind of like take it in. And I always run the risk of putting too much online because then it encourages students maybe not to come to class. But at the same time, having you constantly scratching stuff down and kind of missing discussions, I fear that worse. I want to make sure things are clear when you walk out of here. And the reason I like the videos so much is in case something's not clear, but if it was clear in class, you can go find that spot in class and re-clarify. And that's one thing I often get told by students, like it makes total sense when we're talking about it together. And then I go to A&P, or I go to forestry, or I go to my nursing class, and then I've forgotten everything you said. And that's totally fine. I think this will remedy that to some degree. So anyway, quantitative. This is the data that's actually numerical. And I like to classify it down into 2. And every textbook does this correctly, which is awesome. You can count certain data, and we call that discrete. Or you can measure certain data, and you can call that continuous, and you can call that continuous. So I go back to Tabitha's safety ratings on those cars. I love that. Give me a safety rating, something that we're going to measure from this in the safe range, safe realm of cars. Give me something you're interested in about the safety of a car.
The crash test rating?
Okay, good. In what way? Like how long it takes them to come to a full stop?
Or like how long until the airbag deploys?
Love that, love that. How long from impact to deploying of 100% deployment of the airbag, or close enough to 100%. Love that. So time it takes an airbag to deploy. Airbag, making up words. Airbag to deploy. Friends, it is definitely quantitative because it's a number, it's time. Which is it? Time it takes from an airbag to deploy. Oh, I love this dissension. I heard a couple of discretes, I'm hearing a couple of continuouses. How do you get time data?
Measure it.
You have to measure it, don't you? You can't count time. Why can't you count time?
Because it's continuous.
Well, but that's a good answer. But why is it continuous? That's a very good answer, Chris. Why can't you count time? Because you can't. No. In order to count something, think about things that can be counted. Like I was thinking, going back to Tabitha's example, not so much the time it takes to deploy the airbag, how about number of airbags in a car? Is that discrete or continuous?
It's discrete.
Definitely discrete. Okay, I got one at the steering wheel. I got one by the passenger. I got two of those, what are they called, curtain airbags, I think, curtains that drop down here, curtains. Okay, I got one, the back seats. So you're counting 1, 2. So in order for something to be discrete, there has to be a finite jump between a measurement, whether 1, 2, 3, or 1/2, 1, 1.5, 2, and so forth and so on. Why doesn't time do that? It's very nice. It's steady. From 1 second to 2 seconds. Is there any time between that? Careful. Damn it, there's no second hand on this clock. I love it when there's second hands on the clock. Just think about going
Small
from...
increments.
There's an infinitude of time between 1 second and
You
2
can make
seconds.
the interval smaller and smaller and smaller and smaller.
Exactly. Because the second hand sweeps through. It's a continual, to use Chris's word, sweep from 1 to 2. It doesn't jump from 1 to 2. Jumping from 1 to 2 implies there's nothing in between. There's a 1.5 spot. And there's a 1 1/4 spot and a 1 1/10 spot. Time is like that. Very, very, very nice. Very, very nice. I threw out another one up there. Distance it takes from moment of say, brake engagement to distance it stops. If you're interested in that for safety, is that discrete or continuous? Crystal votes for continuous. I agree with her because you're measuring that as well. So you ask yourself, what do you measure? What kind of things do you measure? We got time, we got distance. What else can you measure?
Speed.
Good, speed. Would it be okay if I called speed a combination of the other two, distance and time? Because it's distance divided by time. And tell me your name too.
Yeah.
Tammy, thank you. I totally agree. Speed is measurable. Good, good. What else?
Isn't that just velocity?
It is. Speed, velocity, distance over time. Yep. What other kind of stuff can you measure? I think there's 4 things, and I can't find a fifth. That doesn't mean there's not a fifth, but I can think of 4. Distance, time, weight, that's a third, and there's one more. You're probably noticing it. Chris noticed it when he walked in here today. What's the first thing you told him when you walked in here today? It's hot. Temperature. Temperature is also a sliding scale. Between 1 and 2 degrees, there's an infinitude of temperatures.
What about light?
Say that again.
Sound.
Sound is a measure of, hang on a second, it's basically wavelengths,
Yeah.
which is basically distance. Yes, you can totally measure sound. Light, same thing, it's wavelengths. But I'm not saying no, you're absolutely correct. What I'm trying to do is break it down to the most basic units, building blocks. So the 4 I found are distance, weight, time, and temperature. Although sound and light, obviously, for sure. Light intensity, things like that. I can't think of a fifth. That doesn't mean it's not out there. It means I can't think of it. And I've been trying for almost 20 years. So I'm going to keep trying. Say that again.
Friction.
That's a good one. But the units on friction are newtons, correct? Because it's a force measure. And newtons are kilogram meters per second squared. Damn it. I'm not saying no. Friction is definitely continuous. No. Tell me your name.
Cheffa.
Chester, thank you. It's definitely continuous, but we can break it down to something. Kilogram meters per second squared. Love that unit. Call it a newton. Call it good. Call it a newton. Yeah, call it a newton. How about something else that's discrete? We got a whole bunch of continuous. Now, give me something else that's discrete that you might care about. Anybody working bachelor during the season? Anybody? Number of people going into a lift. I mean, you might want to keep track of which lifts are the busiest, and maybe those get upgrades. Maybe, I don't know. Why?
The other ones get upgrades. I want pads all the
Yes,
time.
but you have to think like a business person. I'm not saying Bachelor always does that, but you have to feel like a business person. If the lift is busy and you're not upgrading it, then you're going to have fewer people using it, which, oh, the hell with this, I'm going to hoodoo. That kind of, or hell with this, I'll get in that country here and go myself. So, I mean, that's the kind of, I agree. I see what you're saying, Chris, but business and our personal preferences don't always go hand in hand.
Yeah.
Don't always go hand in hand. Cool? This actually happened, any rock climbers in here? This actually happened when the Bend Rock Gym, before it was the Bend Rock Gym, was called something else, because Larry opened it. Incline, thank you. It was the Incline was at the old space down in Arizona, and it moved to the new place over off Reed Market. He built that new gym, designed especially for elite climbers. Place is insane. It's beautiful. I love going to climb in there. But there were hardly any easy routes, and he wasn't bringing any business in because the majority of people that were trying rock climbing for the first time couldn't climb stuff that's upside down. You know, they look up there like, I don't want to play here, and they go back and go. So the new owner that came in, the first thing he did was put in a bunch of slabby climbs, 5, 6, and below, and traffic's gone up. So it goes back to what Chris says. Yes, maybe an elite rock climber doesn't want to climb a slabby route, but people that are bringing money to them do. So I think that's why Bachelor does so well. It's a pretty moderate mountain. There's a lot of blue and green terrain, as opposed to something like Crested Butte, Colorado, which is mostly blacks and double blacks.
Yeah.
So, cool? Does this make sense?
That actually makes sense.
It does from a business point of view, right? It does. And then you have to know where to go to find what you like. And there's a lift that goes there, I'm sure. All right. So, once we've got our data, what we do with our data is the remainder of today. We're going to talk about the rest of today. How we deal with the data that we've gotten. So, there's two kinds of statistics that I kind of want to break down an understanding of today. One of them is predominantly what we deal with in Math 243. It's called Descriptive Statistics. The next bit is predominantly Math 244. We'll get to that in a moment. The reason I want to do both is because some of you I know are not taking Math 244. Right, exactly, inferential and descriptive. That's exactly right. Tell me again.
Stats 2.
Athena, thank you. Yes, Stats 2 is 244. 243 Stats 1, 244 Stats 2. Some of you don't have to take 244, I know that. But there are certain ideas from that I think are important enough to have in this course to send you out of here with a basic understanding of inferential stat. We'll get to that, though. We'll get to that. You may have seen something similar to this map about 6 months ago, 5 months ago. Okay, so who won the election? Barack Obama won the election. When you look at that map, it's kind of hard to believe. It's kind of hard to believe looking at that map because you're like, okay, Barack's blue and Romney's red, and you look at that map and it's mostly red, you know. So how could Obama possibly have won this election if the map is mostly red? And who knows the answer to that? This was made pretty well known. Shelby, thank you. Go ahead.
The electoral votes per state,
And how are electoral votes divvied up?
population.
By population. It's all about population. Yes. I think Romney has either equal numbers of states or more states than and Alaska and Hawaii didn't make this map for some reason. I forget why. One went one way, one went the other, I believe. Correct me if I'm wrong on that one. But yes, it's based on population. Democrats tend to win urban areas, and conservatives tend to win rural areas. Well, rural areas are also, kind of by definition, also very less densely populated than urban areas. For example, Wyoming is the least populous state per square mile than any other state in the Union. It's amazing, right? It's amazing. You think about that. Even Alaska is more densely populated, not much more, but it's more densely populated than Wyoming is. So, when you look at this, you say, oh man, it's kind of misleading. Now, the reason why this is called descriptive statistics is because this is what happened. The data was collected. What kind of data do you think this was? Just out of curiosity. Qualitative or quantitative? Quantitative, because they counted something, right? They counted the number of votes. So a vote for Obama, a vote for Romney. A vote for Obama, a vote for Romney. Okay, good, very good. So you've got this is descriptive because this is what happened. I'm not trying to predict what's going to happen in 2014 in the Senate races. I'm not trying to predict what's going to happen in 2016 in the next presidential race. This is what happened in November of 2012. But this is two. This is two. And I like this map more. Not just because it's so goofy looking. What? It is goofy looking. It's scaled by population of the state.
Weird.
So now, the larger the population, the larger the state. And I love this. I'm from Delaware, okay? I'm from Delaware. Delaware is right here.
Other things.
That little tiny thing that looks like part of Pennsylvania. That's Delaware. That's my state right there, University of Delaware. There's Wyoming, okay?
Whoa.
Look at Delaware. Look at Wyoming. Delaware has roughly an equivalent population as the entire state of Wyoming, crammed into this little tiny spot. Second smallest state behind Rhode Island.
Do you think that's because of the coast?
Oh, it's probably, well, it's also one of the first states to be settled. It's the first state ratified by the Constitution. It's been here for 200 years versus 100 years, 300 years, I don't know, 250 years, something. It's been here a long, I mean, basically the United States was settled here, sorry, all the history buffs in here. It was settled here to here, so we've had more time to accumulate annoying Delaware people.
Yeah.
But I love this, because now you look at that and you go, yeah, of course Obama won. Because now it's mostly blue. Does that make sense? Now, the people that made this map, I forget what kind of map this is. I forget, it's got a name when you just store it based on a population. I forget, it's somebody's name. Here's the popular vote. Notice it doesn't sum to 100%, because there were some third and fourth and fifth party candidates. Electoral votes do sum to 100, though. Here's a fun look at the original map, too. This makes it even less obvious that Obama won.
Is this by county?
This is by county. It makes it even less obvious that Obama won the election, because there's even less blue up there now. Like, for example, Delaware's right here. Okay, so there's Newcastle, Kent, and Sussex counties. There's 3 counties in Delaware. Two blue, 1 red. Okay, pretty obvious. Pennsylvania is right here. Pennsylvania is almost entirely red, except for Philadelphia and Pittsburgh, which is where like 95% of the population of Pennsylvania lives.
It's like why we
more
get
liberal in cities.
it's like why we get screwed by the valley so much.
Mm-hmm. Exactly. Portland in particular, right? Portland in particular.
Yeah.
California, a lot of red, except LA. San Fran's up here, and every other town in between, which I'm sorry I can't think of right now. But you start realizing that the liberals are in the urban centers. But what's cool about that is, again, it's hard to believe Obama won until you scale the counties by population too.
Weird.
And then it's like, oh yeah, there we go. It does, like a big crazy squash Spider-Man logo, exactly. Can you find LA? I'm thinking you can. I'm thinking it's that. Or maybe this. I can't really tell what. There's New York City. Love that. Yeah, New York City's ridiculous. I think there are more people in LA and New York City than in the entire country of Canada. I think. At least it was that way about 10, 15 years ago. I mean, that's impossible to kind of process.
It seems like voting that way kind of undermines democracy.
What's amazing is, and the Electoral College, I believe, was put into place to prevent that from happening.
Right.
And it's kind of gone the other way now, in that they only target the population centers, or what they call swing states, I guess. So, yeah, we could have an entire discussion over coffee about that sometime. But I'd always get pissed off and snort coffee out my nose, which might be entertaining. Might be entertaining. I like this one a lot. It starts getting a little hard to look at. Same map, counties, but now instead of off or on red or blue, it's shades of purple. So it's not even how each county voted. So if a county voted half Republican, half Democrat, it's now like a purple shade. If it voted more heavily Republican, it's more reddish purple. More heavily liberal, it's more bluish purple. So you get this. But again, it doesn't look that blue until you get this vomit-inducing graphic here. In which case you're like, oh yeah, it's still mostly blue. But I like this too, because it is mostly blue, but I think this map is actually closer to these proportions, 60-40. The other one looked almost like a blowout, complete blowout. 60-40 is pretty close. So, at any rate, all of these are descriptive. Because every single one of these 6 representations simply said, here's what happened. This is what happened. Now, if we took that and tried to predict what's going to happen in 2016, that's a different story. That's a totally different story. Because this is what happened. There is no uncertainty in this. But if we try to take this and say, okay, based on this, I think that the Dems are going to sweep in 2016. We've now made a prediction. And that is predominantly what Math 244 is all about, but I do want to talk about it a little bit today. It's called inferential stats. Inferential. And rather than trying to define it, which I found I suck at defining this idea, it's better to go through an example to see exactly what it is. Because I think enough of you have been exposed to inferential stats in your daily lives to kind of get it. So basically what you do is you take a sample from a population that you're studying. So you're interested in a population, but you can't measure the entire population, usually. So say, for example, we're interested in this study right here. Go ahead and read that a little bit. Read that if you can. I know the type is a little bit small, but see if you can get something out of this research article. I could make the screen throw bigger. It seems like there's an awful lot of wasted space over here. I'm not gonna start touching things. Got any caffeine addicts in the room? There we go. Be honest, people.
America.
I got some caffeine. Which is
America.
America. Caffeine. The trick with this one too is study claims caffeine addicts get no jolt from morning coffee. There's a couple, this happens all the time in mass media. As soon as mass media gets their claws on a research study, they interpret it verbally in their own way. First of all, what is a caffeine addict?
Someone that grows a dependence on a substance.
Good. How do we measure that, Raphael? That's very, very good. How do we measure who is and who isn't a caffeine addict? This is fantastic idea, by the way.
You would probably figure out how quickly the caffeine would be
Metabolized?
metabolized through the body over time, because that individual that's an addict would metabolize it a lot faster than that person.
I would have never thought of that. That's a good quantifiable measure. How quickly until, say, less than 10% of that caffeine, less than 10% of that caffeine is left in there. Yeah. Core calculus, very nice. Exponential decay, very nice, yes. So good. Until it's metabolized, good. Withdrawal symptoms, Chris voted for it too. If you can quantifiably measure them. The trick is always about measurement. Whenever you have a variable, caffeine addict, if it's measurable or not. And these two things you guys said could possibly be measured. Very often, there's a great study Stanford University did about proving that people that multitask suck at everything they try to multitask at, on average. Now, I know we have exceptions to that. My wife is a perfect exception. She can do like 5 or 6 things at once, but she's also a mother and a woman. They're just better at multitasking, I think. I can barely walk and talk, which is why I'm standing still. So, but they quantified a heavy multimedia multitasker and a light multimedia multitasker by a series of questionnaire questions that they then combined into one measure. Again, questionable. That's a little questionable because that's a bit subjective. Something like the amount of caffeine in your body, it's measurable. It's measurable using the correct equipment. So that's one thing you always have to pay attention to. When you see something like, the rate of autism is up, ask yourself, what is autism? One of the reasons the rate of autism is up is because they've reclassified things as autism they didn't used to classify before. So you have to get that. What is the definition of autism? What is the definition of a caffeine addict? Good. Also, caffeine addicts get no jolt from morning coffee. This study was done in England. Right, well, exactly. But also I question, just coffee? Tea. How about tea? How about green and black teas? Which also have not as much caffeine as coffee, but caffeine nonetheless, especially if you drink 2 cups of it or 3 cups of it. So again, little things that might make a big difference in the overriding thing. But I don't want to focus too much on that. I want to focus more on who's my population that we're interested in from this study. We care about those that we are terming caffeine addicts. We care about the caffeine addicts, Mike. We care about the caffeine addicts. The problem with trying to figure out whatever they measured, whether it was the amount of caffeine left in the system, whether it was the number of times they blinked in a 5-minute period, whether it was internal body temperature upon withdrawal, whatever it was they were measuring, they couldn't do it for the entire population of caffeine addicts. Because how many caffeine addicts are there?
Wow.
Let's assume we've already got a good measure of what makes a caffeine addict a caffeine addict. How many of them are out there? Millions, if not, maybe even a billion, maybe thousands of millions or a billion, right? Too many to count. And by the time you start counting them, some of them have died. And some have now become caffeine addicts. So now you miss them. Being realistic, what is it? It's every like 5 or 6 seconds somebody dies, somebody else is born. People age into being caffeine addicts, So what do? You don't count them all. You draw a random sample. I mentioned yesterday how hard it is to be random when you're a person. How hard it is. What do you think a random sample implies?
They stood like at a shopping mall and just grabbed people.
Yes, that's actually a very, very poor, I would think a very, very poor random sample. Because has anybody taken a psychology class that got the definition of what a random sample is before?
Yeah.
Go, Chris, go ahead. You've forgotten that. It's okay, Jess.
Not really coming to me. It's I don't really know how to get it.
Let's use a simple example. In 105, we rolled dice quite a bit. You throw a single die. What's the chance of any one of those numbers showing up on a single die? 1 out of 6. Every single number has the same chance of coming up as any single number. That's what a random sample is. Think of a random sample as a die with as many faces as there are members of the population. So think of a billion-sided die, of which you are one of those. If you caffeine addict, I'm on there. I'm over here. And you roll that die, and you've got just as much chance as anybody else of being selected. That's why, is it, no, Tabitha's over here. Wait, no, you are Tabitha, damn it! Week 1, Tabitha. That's why standing in a parking lot asking people is kind of a shady random sample. Because unless you go to that parking lot, I don't have any chance of being selected in that sample, right? Only those who go to that parking lot. Those are called self-selected or actually they're called convenience samples.
So basically you have someone that self-identifies first as a caffeine addict and then rate them as how addicted they
Absolutely.
are.
I think Tabitha was going more generally than just the caffeine addicts though, Raphael. She's saying, is this a way to get a random sample? So suppose you just wanted to get public opinion about something. So you stop every 10th person getting out of their car at Food for Less. Totally fine if you're interested in those that shop at Food for Less on Saturday morning between 10 and 12.
Yeah.
If that's your desired population, you may have gotten it. But if you want the average Bendite's opinion, you probably have to scatter a little bit more and get a little bit more of a random sample, increasing the likelihood that everybody in Bend has a chance of being selected. Just so you know, I have yet to see a study in 20 years of looking that's perfectly random. Because it's almost impossible to do. Gallup, we're going to look at a Gallup poll here momentarily. Gallup does a great job of pseudo-random sampling by using random digit dialing on phones. You guys get hit with this almost every electoral cycle. You look at your phone, the caller ID, and you see Democratic National Convention, or the hell they are calling you to get your opinion, and you probably don't answer it. Exactly. But that's how they're getting your number. They're randomly generating your number. So they're pseudo-randomly dialing. I call it pseudo-random because number one, it assumes that everybody has a phone.
Yeah.
Which is not necessarily true, although it's more true than it used to be. It's a better assumption than it used to be.
Didn't that happen in one of those elections where they called people and they were just calling people that had phones?
Yep.
They were more Republican.
It was Dewey Truman.
Yeah.
It was Dewey Truman. The Dewey Truman election, we're going back about 100 years now. But there's a great picture of a dude holding a newspaper that says, Dewey defeats Truman. And the problem is, it's Truman holding the paper because he just won the election. But what happened was they used phone call. This is back in 1940. And of the people they called, it was a landslide for Dewey. But the minority of Americans had phones at that time. So yeah, the majority of those who had phones were going to vote Dewey, but that was hardly anybody in the population in general. It's like calling Wyoming, trying to call the election from Wyoming alone. You're getting kind of a skewed perception there. So don't worry in this class too much about how the sample was drawn. We'll worry about that a lot in 244, I promise you. And you'll worry about it even more in research methods classes later on.
Oh, wow.
Well, if you have to take them. Some of you may never have to take them. Research methods, you'll deal with it then. You'll have an entire class devoted to it. And you should. You should. Because statistics is only as good as the data you feed into it. So, why do you do this? So, and also, don't get too upset. Is anybody concerned only 379 adults were polled?
Yeah, that's not a lot.
That's not a lot, but believe it or not, it's enough.
Completely random.
I'm more interested that it was done randomly than it's only 379. And we'll deal with that in 244 as well, those who've taken that journey with us. It's okay. It's enough. Never question those numbers here in this class either. I'll make sure you get decent data sets that we can actually do stuff with. Liz, that was concerning you too?
Yeah.
Yeah. It's okay.
Last time we learned that it took us to about 1,000.
Oh, that's only because I could simulate that totally random. I just told you Liz. That.
Yeah.
I've never Liz, but don't be called Liz. I'm sorry. I gotta keep it all straight now. No, that was because I could hold down the F9 button and let it run essentially forever. But that's purely random data. And you can't just do that with a research study because you run out of funding or time or both.
Right.
And the thing is, you can have a small sample. You just have to accept what's called a larger margin of error, which we'll get to here momentarily. So don't concern yourself with that too much because it's a big enough. You're going to in 244. One of the things we do in there is we actually estimate how much oil came out of the BP Deepwater explosion using 6 data points. And with 6 data points, we get much closer than BP got with their initial estimate, which was complete and total crap. And we get almost exactly what the Coast Guard got with all their multi-million-dollar budget. It's 6 data points is all you need. So you don't need thousands. Sometimes hundreds does just fine. Okay, what we're interested in is a parameter. That's what we want to know about. That's the measure of the population. Whether it's Raphael, the amount of caffeine that is metabolized over a set period of time. That might be it. Or whether it's the number of times, on average, a caffeine addict blinks when denied caffeine per minute. I mean, whatever, that's what we might be interested in. The problem is you're never going to get it unless you actually ask everybody in the population, which the United States adorably tries to do every 10 years with the census. They're so cute. I think they finally learned. They are. The United States is adorable sometimes. We're going to have every person. That's because it was put in the Constitution when there were like 22 people living in the country. Like you could go outside like, yeah, we're all here. Good, check. So I think the Census Bureau is finally going to come over to use statistics again and draw random samples and extrapolate from that, but more on that to come. You're never going to get a parameter. You're going to get a statistic. From that statistic, you can extrapolate out some kind of an idea about the parameter you're interested in. Now, right here, I didn't show you enough here to deal with these two terms, to understand what these two terms actually are. So I'm going to have a Gallup poll up here in a minute that's actually going to help us understand how you can take a statistic and estimate what the parametric value actually is. So what I want to do is I want to jump over to that one. Here's a Gallup poll. We're going to get the coffee drinkers momentarily. We're going to come back to this idea of parameter and statistic here in a minute. So up here, there are, well, there's the headline. U.S. oil drilling gains favor with Americans. Subheadline, support for offshore drilling and oil exploration in Alaska reached new highs. So there's two claims there. Support for offshore drilling is at a new high, and oil exploration in Alaska, support for that is also at a new high. So two claims. Both the claims are drawn more detailed in those two charts underneath. So if you look at the first one there, American support for U.S. offshore drilling. Do you favor or oppose increasing offshore drilling for oil and gas? 60% favor, 37% oppose, 3% no opinion. Now, I'm okay with all that because they drew a sample. Can you see their random sample, friends?
Yeah. Can
you see the random sample? You have to look to the bottom of the slide. Look to the bottom of the slide. And this will always be somewhere on a Gallup poll. Based on telephone interviews conducted March 3 to 6, 2011 with a random sample of 1,021 adults. There's your random sample. It's enough. I promise you that. It's enough. You get 95% confidence.
1,000 adults is enough to
It is.
say
It is.
350 million?
It is. It's not based on proportion. It's based on error. And there's the error right here. Margin of error is 4 percentage points. We'll come back to that in a second. But yeah, because you have error involved, Chris, you don't have to have a fixed percentage. More on 244. I promise you. Okay, so, and they did a pseudo random random digit dialing. So we're going to call it, we're going to pretend this is random enough. I am a little concerned with the fact that it's only in the continental 48 states, and they're asking questions about Alaska. A little concerned about that. But I'm not as concerned as if they were asking questions about California and not interviewing Californians. Because Alaska's population isn't so much, I don't think, to sway these numbers all that much. Because assuming it's purely random sampled, the chance of getting an Alaskan is pretty small in a purely random sample of 1,000 people. You're going to get mostly New Yorkers and LAites, whatever the hell you call somebody from LA. No apologies to anybody from LA, that is, I'm ruining your town's association name. Here's what I have a problem with. Do you favor or oppose? 6 in 10 Americans favor increasing offshore drilling. So the sample is the 1,021 adults. Who's the population?
18 plus.
18 plus Americans, correct? 18 plus adult Americans, right? In the continental United States. So 18, basically Americans, right? So if the population is Americans, they're telling me that 6 in 10 Americans favor offshore drilling. I don't believe that. I believe that 6 out of 10 Americans favor offshore drilling.
The middle of the country.
You're thinking too big. Who did they ask?
Continental.
Who in particular?
18 plus.
1,021 18 plus people. 6 in 10 of those people said they favor offshore drilling. Not 6 out of 10 of every American. Now here's the question. Assuming the sample was done well, should it be close?
Yeah.
Should be close. But how close is close? That's where
Margin of error.
that comes in. This tells you how much uncertainty you have to accept with that 60%. So they say 60%, but it might be up to 4 percentage points lower than that, or 4 percentage points higher than that. So this 60% might be as low as
20.
56, careful, 4 to 40.
Oh, okay.
There's that prerequisite, baby. I'm glad I put that up. It could be as low as 56%
Or 64.
or as high as 64. Just like this 37 could be as low as 33 or as high as 41. So you can't tell me that 6 in 10 Americans support it. What you can tell me is I believe that between 56 and 64% are in favor of it. It's a slight difference, but it's a correct difference. It's a correct difference. However, I'd like to make this claim. Tell me what you think. Is it right to say that a higher percentage of those surveyed, or a higher percentage of Americans, and we'll use the margin of error, is it correct to say a higher percentage of those Americans favor instead of oppose offshore drilling, using the margin of error?
Yes.
Yes.
Absolutely. Because the lowest this could be was, what did we say it was going to be? 56%, and the highest this one could be is 41. So therefore, I can say with this level of confidence, which we'll deal with in 244, that I am confident that a higher percentage favors than opposes offshore drilling. That make sense? That's the correct thing to do with those numbers. Don't tell me 6 in 10 Americans believe. I don't believe that. Just like telling me that the majority are now opposed to the war in Iraq. If it's 53% plus or minus 4%, you can't prove to me that it's over 50%. It might be below 50% with that 4% on there. By the way, I'm giving you an answer to the 7th-day question from yesterday. I just realized. So go ahead and have fun with this. Yes, go ahead and have fun with it. Okay, let's take 5. You're starting to get that glazed look. All right. So the original article said support for offshore drilling and oil exploration in Alaska reached new highs. I think we buy the first one. If we can live with the removal of Alaska and Hawaii from the sample, I think we agree that more people favor than oppose offshore drilling. Do we agree that more people favor than oppose drilling in Anwar?
Is it still the 4%?
Say that again, Tabitha.
Is it still the 4%?
We're going to assume this margin of error applies to every single poll because that's what they told me it did. So do we agree, based on those results, that more people, I don't agree either. I agree that more people in their sample agreed because 49% is bigger than 45%. But I do not agree that that extrapolates out to all Americans because once you apply the 4% to it, the percentages potentially could overlap or even be the smaller one be greater than. So, for example, 49% might be as low as 45% or as high as 53%. 45% might be as low as or 41 or as high, or it could be 44. But it could be as low as 41. Prerequisite, very good idea. Could be as low as 41% or as high as 49%. So this guy here might be at 47. This guy here might be at 48, and it might actually disprove what they're claiming. So what this is called, Gesundheit, a statistical dead heat. You may have heard that phrase in election years. When Romney's at 48% and Obama's at 49. Yeah, 49 is bigger than 48, but with a margin of error of anything more than 0.5%, you can't prove that Obama's actually ahead of him in the general population. In the sample, yes, it doesn't extrapolate out to the population. This definitely extrapolates, for sure, because it's so far apart. It's more than a margin of error apart. These are too close.
Well, isn't it saying last
Francesca.
year reaches new highs, so does that mean they're comparing it to some other study that they're not mentioning?
They often do that, as a matter of, is it Francesca? Am I saying the right name?
Yeah.
And I said, they often do that too. Gallup will have time lapse, March, April, May, June with a little line chart. The thing is, when you apply a margin of error to that, it's basically the same number. It might trend downward from, say, January to January, but from month to month, it goes nowhere. So yes, I see what you're saying. It might be higher than it was the previous survey.
Well, they aren't trying to prove that, so it really doesn't matter.
Exactly. But as soon as they say reach new highs, it almost sounds certain, doesn't it? It sounds like they are insinuating a proof. And this is the gray area of statistics right here. You've nailed it, Francesca. It's the gray area of statistics. It's taking a sample and saying a little bit more. The problem is I can't even claim that this is as high as they say it. They're saying 49%. They're saying 60%. You can't tell me that that's actually equal to that number when it could be 4 percentage points lower or 4 percentage points higher. That's my biggest, my biggest, this is a little bit of 244 I try to sneak in, is making sure you pay attention to that number right there when you read these kinds of polls. Cool? Makes sense-ish? Yeah. And if you can't find the margin of error, don't believe the poll. Any poll worth the salt will give you that margin of error. Please, Ariana, go.
So what do we do when they say, like,
Well, I would turn the radio off if they say all Americans do anything except pay taxes and die. But, oh, you use the Google, as my dad calls it. Use the Google, otherwise known as the Force. Yes, do a Google search for the topic and track it down and see if you can find the source data. Always. And like that caffeine article I showed you earlier, if you scroll through that enough, you'll find hyperlinks. Go backtrack them. And eventually you'll get to the source data, and chances are the source data will have roughly 40% in common with the final result. Twitter raises your GPA. This is a published study. Twitter raises your GPA. I encourage you, if you want practice Googling, go find that study. Twitter raises your GPA. If you want practice in good fact checking and Googling, go find the published study that proves that Twitter raises your GPA. just in case you want some practice fact checking, go find that one. Cool. It's answering your question without answering your question, Ariana, but that's the best thing is go fact check it. Show me the data. In God we trust. All others must show numbers. Yeah? It's a statistician's creed. Yeah. All right, speaking of these numbers, what do we do with them? Okay, what I want to spend the rest of the time today doing is talking about, once you have this wonderful data that we're talking about, how to actually get it out to the world to present it. One way is simply dropping raw data in somebody's lap. That number there is a 28. Sorry about that. So these are fictitious numbers. I made these up with a random plan in Excel, but I put some context on there too. So a fictitious company with 20 fictitious employees that don't actually exist did this many products per week. So suppose you're the head of this company and you're trying to track employee productivity. And you want to know how many products your employees are producing per week. All right? Now let's say all things being equal, these employees work the same number of hours, they have the same skill set essentially, they have the exact same skill set, they're apples. Who's the slacker as far as defining slacker as producing the least number of products?
Number 10.
Who's the slacker? Number 10 guy is the slacker. Who's the overachiever, assuming that the most number of products
39.
is... Say again? 39. Okay, 39. Should the slacker be punished?
Probably.
Or reprimanded? Or encouraged to work harder? Probably. Why do you say probably, Kevin? Just out of curiosity, why do you say probably?
Well, the closest to his number is 15.
I love this. The closest to... I'm calling him slacker. It's a terrible term. The closest to 10 is 15. 14.
Oh, 14.
But you've actually proved my point here. Raw data, this is raw data, is wonderful because you see exactly what happened. But what's hard about dealing with raw data? Seeing where the numbers lie with respect to each other, kind of sorting them, right? So raw data has an advantage in that it's great. You see everything. This person made 30, that person made 19. The problem is, even when I asked you the first question, who's the slacker, you had to kind of scan through to make sure 10 was the smallest. And who's the overachiever, you had to scan through to see that 39 was the biggest. So that kind of scanning. So the advantage, you have all the real data, it's all there, it's all raw. The disadvantage is it's a little bit more unorganized. One thing you can do is put it in order, and we'll deal with that on Monday with some data that we'll collect today. But another way that you can actually do it is put it in order and group it in something that I like to call a distribution. You guys have seen things like this in previous classes. You used to call them T-tables probably in algebra classes, X, Y. Same exact idea, but less algebra. Now it's going to be X and F for frequency. So what I've done is, same raw data set down here, but I've grouped it into ranges of 10 to 12, 13 to 15, 16 to 18. So I've made them in, I think they're called classes or bins, depending on who you talk to. Bins that are 3 units wide, 10, 11, 12, 13, 14, 15, 16, 17, 18. And remember, I'm going to have this posted for you later, so you don't have to worry about writing all this stuff down. What's the advantage here over the raw data?
Can I see the averages a little bit?
Oh, good. Tell me, Cassie.
Yes.
Cassie, tell me give me a definition of average that you're using here. I love that, by the way. What do you think? What are you thinking?
What majority, the majority of
Love it. You're using the mode as an average, Cassie. Excellent. So what were your eyes drawn to, Cassie?
I was drawn to this between 16 to 18 and then the 19 to 21.
That's fantastic. That's fantastic. They're both 5s. If there are 20 employees, fully half of them are between 16 and 21, which means the big spread from 10 to 39 might be a bit superfluous, which Tabitha was actually hinting at earlier by saying 10 maybe, 39 maybe. So good. Your eyes are drawn to good. Very nice. Other reasons this is good. I love that reason. And the other reasons why it's good. You don't have to use the word average like Cassie did. That was really cool to use it. But any other reasons, it's just, is it more aesthetically pleasing? In what way do you think?
It's organized, yeah.
It's easier to,
Read. It's easier to look at and understand.
there's 4 letters in your name. There's 4 letters in your name. Tammy! There's 4 letters in your name, and there's a vowel. For some reason, I can see the lengths of names before I actually get the names, but that's the first step. So good. Good. It's in order. You can. Yeah, good. Give me one disadvantage of having it in that respect versus the raw data.
Well, with this kind of stuff, it can also be going, you have to go through a sea of mess. Like
Tell me how, Raphael.
extrapolating the data and looking at it.
I see what you're saying. What you're saying is if we want to take this to infer something, don't take that step. Just looking at the data this way, I love what you're saying there, by the way, but just looking at it this way versus this way. I think we've got some good advantages to this over this. Give me a disadvantage.
Not exact,
Tell me how, Francesca.
because you don't get all the information. You don't know exactly who or how many people did what number.
Nice. 5 people got between 19 and 21 made, but you don't know how many 19s, how many 20s, and how many 21s. We have a solution for that. We'll deal with it on Monday. But that is a downside. And the bigger you make the bins, the worse it gets. If you made the bins 10 through 19 and then 20 through 40 or something like that, or 10 through 19, 20 through 29, and then 30 through 39, it would get even worse. We have a solution for that. We'll deal with it on Monday. But that is kind of the big problem. Or not the big problem. It's an issue. You lose a little bit of exactness. But you don't have to worry about that too much. Do the stuff we'll see next week. Very nice, very nice. Although this is good. Somebody said it's a better visual. There's even a better visual that we can use. This is one-dimensional, but there's still something that's lost. I asked you, yes, if we make it two-dimensional, because really it is an X and a Y. So let's make it truly X and Y. I make it look like this. This is called a histogram. Sometimes it's just called a bar chart. I think Excel calls it a bar chart, which is fine. The technical statistical term is a histogram. That's fine too. So what you do is you take that and slap it into a second dimension. Now, you have the same limitations here that you had there. You still don't know exact values. But how is this better than that?
You can instantly see everything.
Your modes pop right out, Cassie. Your modes are right there. Shoot, 5s. And what's cool is they're also scaled proportionately. This is now 5 times as big as this. But the number 5 is not 5 times bigger than the number 1. You could make it be that way. It's kind of annoying, actually, if you made it like a font size 5 times as big. Kind of comical. But you don't have to. It's why I have histograms. Also, what else do I really like about this? Or maybe you've noticed it too. What else pops out really clearly here that doesn't pop out there? Besides the mode, which definitely does. The empty spots. Those empty spots. Yes, Big Mike. Yeah. Tell me your name one more time, my friend. Athena, thank you. The empty spots, the zeros that were up there, you really see the separation. So my question, I'm going to ask it again to Tabitha and everybody else. Is the 10 that unusually small? All of a sudden, we're shaking our heads. Good. Tell me your name next to Raphael. Angie, thank you. You're saying no because? Go ahead, Angie. It's like part of the bell over here, if you will, right? Is the 39 perhaps, or whatever this value is, because we can't exactly tell, is the person out here unusually large? It does kind of seem that way. You've got this big chunk of data here, then a small gap, and then a secondary spike, another gap, and then boom, more. Now, this is not to say if we collect a few hundred more data points, that this might become a bell curve. And we'll study that in this class too. It might turn into just a bell curve, in which case none of the values would be unusual. But right now, the 39 is looking more unusually high to me than the 10 is looking unusually low, if that makes sense. Cool? I'm not saying that's exactly what's going on. I'm saying that's what it looks like to me when I first look at this data. But I do think we get a little bit more with this than we do with just this. There is a downside that you might not realize yet. In order to do any kind of mathematics on this, you have to use that. That's what makes mathematics helpful for us. And we'll talk more about that on Monday or Wednesday of next week at some point. Cool? So those are histograms and distributions. I love distributions. It's a very organized way of presenting data, and this is a great 2D look at that. What I want to focus on now, I mentioned your textbook very often presents lots of stuff. They front load you with a lot of stuff. And then they back off and say, remember this in like 5 weeks. I want to stick with just the histogram-y types of charts for the rest of the day. Until the very end. I want to drop some fun stuff on you that is not part of the course technically, but I think you might enjoy. So the first one's called a Pareto diagram. In order to get some data for this, though, I want to ask you to do some math in your head. So what I want to do is I want to ask you a bunch of math questions. I want you to answer them in your head, not out loud, but in your head. And then at the very end, I want to ask you a non-math question that I want you to either write down or just keep in your head. Okay? So clear your minds. So, bunch of math questions. Answer in your head, not out loud, in your head. 1 plus 5. 2 plus 4, in your head. 3 plus 3. 2 plus 4. 5 plus 1. 0 plus 6. 1 plus 5. 3 plus 3. 2 plus 4. 3 plus 3. 1 plus 5. Write down a vegetable. Good. It's always about 5 seconds till somebody laughs. I love that. This guy does appear to smell a lot of crap.
I think you have hypothyroidism.
I'm thinking, according to my doctor, it's hypo.
Oh, hypo.
Hypo.
Too much.
Yeah, I'm not thinking I'm showing very much hypothyroidism. Okay, let's hear some ideas. What do you got? Carrot. We got carrot, we got broccoli, tomato,
Cucumber.
Cabbage.
I heard something once. This is a great quote. Wisdom is knowing, wait, hang on a second. Knowledge is knowing a tomato is a fruit. Wisdom is knowing not to put it in a fruit salad. Love that. Love that. So awesome. Cucumber, give me one more. Eggplant. You can grow all of these in Central Oregon if you baby them enough. Grows very well without babying, very well without babying, lots of babying, they'll grow very well. Moderate amount of babying, grows fairly well, surprisingly. Kind of tough though. Every year they're very tough. So, anyway, I know we probably have more. Give me one more. Cabbage or asparagus. I relatively recently found asparagus is perennial. Any gardeners in here?
Yeah.
Asparagus is perennial. Fantastic. It's a beautiful plant. It's already starting to bloom. It's the first thing in the garden to bloom. I love it. Keep the chickens out of it. All right, how many carrots do we get? How many carrots? Got a lot of carrots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh, I had a carrot.
How many? 11.
Sorry.
This goes to 11. Yes. How about broccoli? Broccoli, yes. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's about right. Tomato? Got 1, 2, 3. Cucumber? We got 1.
Oh wait, not those.
We got 2. It's all good. Eggplant? Oh, there we go. 0. Cabbage. We got a cabbage. Okay, this is perfect. This is perfect data. And I know we probably have others. Let's go with the data. Beautiful data. Yes, very nice. Yes, can you see that? Yes, very nice. All right, back to here. So what I want to do is I want to make a Pareto diagram of this. So essentially, in words, what a Pareto diagram is at heart, it's a histogram for qualitative data, essentially is what it is. So what you do is, here's your data. It's not numerical, it's qualitative. So it's a bar graph. Instead of having numbers on the horizontal, you've got words on the horizontal. What makes it Pareto is, you arrange the values on the horizontal from highest to lowest values. So we're going to put carrot, actually this came out that way, highest to lowest, which makes sense actually if you think about how we randomly sample. So we got carrot, broccoli. So I spelled that wrong. 1L2. Yeah, that's right. Broccoli, tomato, cucumber, eggplant, and cabbage. All right. Should I use shorthand? And then you just scale the y-axis so that it's logical. It goes to 11. Yes, it does. So we'll go to 12. We'll scale it by 3s, I guess. So we'll go carrot. And you can get all purist if you want to and tell them the bars have to touch, the bars don't have to touch. It doesn't matter to me. I think Excel defaults to not having them touch, so that's whatever. It's all good. You're not losing any data by not having it touch. Pareto diagrams will always, if they're truly Pareto, will have this exponential kind of shape to them, exponential decay shape. And the idea of it is, the reason it's called a Pareto diagram is because Vilfredo Pareto, an Italian in, I want to say the 1800s in Italy, made a claim called the 80-20 principle. 80% of the wealth is held by 20% of the people. So the lion's share of the data is in a very small group of data points, the lion's share of the frequencies. And I think that's probably true even today if it's not 90-10 or 95-5 along those lines. And some Pareto diagrams also have a secondary polygon that goes this way to 100%. I don't like to focus on that too much because it's too much like an ogive, which we'll get to later. So there you go. It's histogrammy. It's histogrammy. But it's qualitative histogrammy versus quantitative histogrammy. So, and Excel can do these just like I did the other one. But it's always fun to get the data from you guys in class. Does that make sense? So qualitative versus quantitative. Excellent. Get a good shot of that one? That was not bad. Yeah, that damn wide angle. That's all right. It's okay. We got it. We got enough of it. Enough of it to see what's going on. Still recording, right? Yeah. Okay. So that's a Pareto diagram. I'm going to show you 3 words here. Fingered, refused, slaughtered. I know we haven't talked about this too much, but what I want you to do is tell me what the average length of one of those words is. The average length of those 3 words. What would the average number of letters per word of those 3 words be?
6.
And I know that we haven't studied what an average is, but I think we've all taken averages before in our lives. I mean, remember when I was in 2nd grade, I figured out really quickly that I couldn't get an A in spelling because I got a test taken away because my mom thought I was cheating on it. Still scarred by that. And
8 letters.
I hear a vote for 8.
7.
Beth says, I hear 7. Do I hear 6? Is it 8? Chris says 8. Well, let's figure it out. Figure 6, refused is 7, so that's 13. And then we got what? 11 in slaughter. So 13 and 11 is 24 divided by 3 is 8. We live with that. So you see what you guys just did? You got an average of 3 numbers. You add 6 plus 7 plus 11 is whatever it was. 24 divided by 3. I'm going to show you I'm going to show you these words and a few more on the next slide. I'm going to give you 10 seconds for your first inferential statistics assignment. I want you to figure out the average length of the words on the next slide. There will be too many for you to do in 10 seconds. So do the best job you can and approximate that average. And give me 1 decimal place of accuracy. So this will be 8.0, right? 8.0 or 7.1 or 7.5 or something along those lines. Fair enough? Fair enough? Okay, good. There we go. Shh, you're wasting time. You have 10 seconds. Anybody recognize that?
Yeah.
Beautiful soliloquy. Yes. Good. One of the greatest movie, in my opinion, of all time. And this is a non-quantifiable statement. Has anybody not seen The Princess Bride? I am so jealous of you, Chris. I am so jealous of you guys. Because you have not seen the greatest movie ever made. Which means you get to go see it. For the first time. Which is amazing. Which is amazing. Which is amazing. Okay. So, you didn't have enough time to count all the words up. But let's figure out, let's see what kind of numbers you guys did get. Let me hear some ideas for averages. Average length. 7 point what? 7.5?
7.5.
Anybody below 7.5? Do we have any 6s? Do we have 5s? Do we have any 4s? You got a 4? Do we have a 3?
$1.
We have a 3? 1, 2. I'm just trying to get a range. 2? Anybody say 2 point anything? Okay, 3's the lowest. Anybody 8 point something? Any 8s? Any above 8? Okay, everybody guessed between 3 point something and 7 point something. This is perfect. This always happens, which is nice. It's perfect data for what's called a stem and leaf plot. Let me see if I can put this, see if this does this pretty well. Go over to the sideboard. This might work. We'll give it a shot. So a stem and leaf plot or a diagram. So what you do is, it's going to be histogram, not Pareto-ly. Because it's quantified, it's quantitative data. You guys are giving me a number, an average length. But all of your values fall between 3 and 7. We're going to call these the stems. And this is beautiful for you guys that are doing field work. We got any natural resource folks out there? Yeah, we talked about that earlier, right? When you're out in the field collecting these numbers, it's very easy to collect numbers very rapidly this way. So if you need more accuracy than just whole numbers, now what you can do is just read off to me. Who said 3 point something? 3 point what?
5.
3.5? Chris, you were 3 point something, weren't you?
I would say 4.2.
Oh, 4.2. Anybody we got 3.5? So 4.2. Any other 4s? 5s. Throw them out.
5.5.
4.5?
8.
0.8? That's it? Okay. Sixes, throw them out.
6.3.
0.3,
0.2.
0.2, 0.5. Who the hell's not voting? 7, 0.5. People.
4.
There's like 80 of you in this room. 0.4.
There's only 36.
I'm gonna start making up values.
Well, maybe that's all. If we.
Oh, but we gotta count them more than one time. If you heard your number, count. You have to count your value again. Because I mean, if there's a bunch of 6.5s, I want to see that. 6.3. Okay, yeah. You gotta count repeaters for sure. Just like 11 of you said carrot, and I counted that 11 different times, not once. Anybody wonder why so many people thought carrot?
6 letters.
What about broccoli?
They're the two most.
Oh, it's still 6 letters, but doubled.
They're the two most.
Clever. Cammy, 4 letters. Speaking of letters, that's clever. But carrot will be 5 tonight. That argument. Damn, the mind is a wonderful thing. I have no idea why this happens, by the way. It just does. And it's always a tie between these two. So this is my ADHD that we're talking about. This is right. What's that? Say it again.
I want to know what people would think. You said name a vegetable.
You know what's interesting?
Because I would think.
What I used to do is, when I was talking about random samples, I would say, how many people like broccoli? This is like an hour ago. People would say yes, and I go, how do you know? And I say, well, because I've had some. Oh, you've had a sample of broccoli, blah, 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 population sample, blah, blah, blah. And then an hour later, I asked this question, and I would always get a lot of broccoli.
Yeah.
And then I realized what I was doing. I was actually feeding, I was biasing the answers. So I stopped saying that. But the damn broccoli still keeps showing up anyway. So something about these letter combinations pop up. I don't know why. Okay, let's fill up the stem and leaf though, huh?
6.4.
6.4.
4.2.
4.2. Another 4.2. Excellent.
3.5.
3.6 and
4.5.
4.6. I heard a 0.5 somewhere.
6.5.
6.5. Yeah, I'm really glad you said something, Lucas, about you heard your number. You want to count it each time because that is a discrete data point again. Good. And this is plenty now. So what you see, can you see the histogram? It definitely. What you want to be careful about when you're doing them manually is that you space them uniformly so that you can actually see those bars that are made by the actual numbers themselves.
So what actually is it? What is it actually?
It's just under 4.
Oh, wow.
It's just under 4. Check this out. Yeah, let me slide this back over. That actually doesn't look horrendously bad. Yeah. Let's go back to Inigo's soliloquy. And the reason I think so many of you guessed higher, I think the reason is it's your first example of bias in sampling. Your eyes are drawn to the large words. Challenged. 11. Dedicated. Demanded. Returned. Promised. There's a lot of eyes. A lot of eyes. A lot of my's. A lot of I's, a lot of to's, a lot of me's, a lot of he's. Each one of those words counts one time. So when you did 24 divided by 3, I think there's about 100 words in this. And it works out to be like 3.96 or something like that. So pretty interesting. But your eyes are biased towards the big words because they take up more space. Kind of cool, huh?
So there's more than 100 words.
More than 100 words? I believe that.
Like 15 lines, and each line has about 10 words in it.
Well, we'll say 150 then. How's that sound? We're going to use an average right now. I love this. Yes. We're going to call it 150. But too many to count. No, it's very, very good. That's actually a pretty slick way of getting a sample. Randomly kind of go down like this through it and pick one word, and then try to divide by 10 really quickly. Because dividing by 10, you move the decimal place one over to the side. Don't tell the next 243 class that. All right. So stem and leaf, yay, we're happy with that. A dot plot is one more histogrammy tool. And it's kind of like a combination of a stem and leaf. But it's when you have even less. The reason why you're like, oh, I never told you what the leaves were. These are the leaves out here. I'm sure you figured that out pretty quickly. These are the leaves. I'm sure you can probably put that together pretty quickly. A dot plot is like a more general stem and leaf. It's still based on quantitative data in general. It could be qualitative. It's very, very general in that respect. Rather than talk about it, let's just get some data. Okay, clear your mind. One simple question, one simple answer. I want you to write down a whole number from 1 to 4. That's it. This. I think I can probably, yeah, we got space here.
looked on your big boards?
Oh yeah, very, very
Boards
good.
all
I think
around.
the chicken problem is going to be wonderful in here. Because we're going to need all of them. Yeah. Say again?
Use the glass windows at the back.
Oh, I brought markers for that. I have a white opaque marker, yeah. I think we probably won't run out of boards in this room, though. But if we do, I use a periodic table, too, so let's look at dry erase. So, these are the jokes, kids. The reason why this is kind of like a stem and leaf is because I know how many stems there are, don't I?
Yeah.
There are 4. 1, 2, 3, and 4. So it's kind of like a stem and leaf in that you've got a set, small, finite number of stems. Now, really, there are no leaves. There's just going to be a frequency count, a pure frequency count. So here, you've got some detail in the actual data point. So what's cool about this is you get the frequency, but you also get the raw data. That's why stem and leaves are cool. You get the frequencies and the raw data. With dot plots, there is no raw data other than those 4 data points, just how many of them there are. So how many of you said 1? Well, I said, hold on, from 1 to 4, you have 2. So I'm going to go 1 and 2. Beautiful. How about 2s? How many 2s we got? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Same idea with a dot plot. You want to keep them roughly the same scale. That's a little too big, I guess. There. Keep it scaled. 3s, friends. 3s. We got 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15. Oh, 15, Miss Chris. 15. And 4s. 1, 2, 3, 4. And this distribution almost inevitably happens. 3s is always the most, followed closely sometimes by 2. 1s and 4s fall off. So next question I have is why? I did say between,
Yeah.
but there are 2 numbers between. Oh, so why are there more 3s than 2s? Because I have yet to have a class where there are more 2s than 3s. It's always more 3s than 2s.
You said 1, 2, and 4.
Because when I asked you the question, I said write down a whole number from 1, 2, 4. So even though I didn't say the number TWO, your brain process, I'm guessing this is why this happens. I'm guessing. I have no idea if this is actually true. But your brain heard 1, it heard 2, it heard 4, and then we said 3! Like your brain modally just jumps to whatever number's left. As human beings, we want to complete patterns. Or not. Cassie's saying, no, I didn't do that at all. That's totally fine. Yeah, okay, Rule, whatever you say up there, you and the camera. So this inevitably happens, though. The 1s and the 4s are very, very minimal, and you follow by the 2s and the 3s, and the 3s always eclipse the 2s by a little. So a dot plot is, once again, a very good field histogram, when your data is even less detailed than for a stem and leaf. So these are all histogram. You can see the histogram in the dot plot. These are all histogrammy type things. And that's what I want to kind of finish with as far as histogrammy type things go. But I kind of want to finish, this is not, what I'm going to show you next is not to test you on. So don't worry about the stuff that's coming on in these last few minutes here as being on like an exam anytime soon. There are some really, really cool ways that artists have found to present data that really kind of break the norm. Here's an example. Rather than talk about it, just check this out. What do you get from that? It's a flag. It is. One second. Should have thought this earlier. Yeah, I should have thought this earlier. It seems a shame to block me. Is that getting any better at all? Ish.
There's no light.
Yeah. Oh, sorry. So I put that every blind for the ones that are actually generating sunlight. Oh yeah, we're in the afternoon now, aren't we? Sun's over there in the southwest. There we go. Ahoy! That looks no better than it did when I started. Son of a!
It's slightly greener. So
It's slightly greener. Let's make it even slightly greener.
There you go.
oh, green.
I'm exhausted. I'm not gonna lie to you. What are you seeing, friends? What are you seeing?
A lot of green.
A lot of green. Why is that impressive? Or impressively depressing?
Because they live in the left or have less than $10 a month.
What you're seeing is you're seeing wealth inequity
Yeah.
in the country of Brazil. What's amazing about this is almost spot on what the Brazilian flag looks like. There's a little white banner that goes across the Brazilian flag. It's got some phrase in Portuguese that means like, Ronaldinho was the greatest soccer player of all time, or something along those lines. But what's interesting about it is people that live with fewer than $10 a month, what percentage of that flag would you say is green? Roughly half, yeah. And then you've got, how about yellow? Yellow and blue are roughly the same area, I think. I mean, when you pop the blue out of it. So say a quarter and a quarter, and then you've got this very sprinkled white star bit in the middle, which are the rich. I know there's some holes in the argument. What about between 1,000 and 100,000? Where do those folks live? That's not the point. The point is they took something extraordinarily unstatistical and made it statistical. Here's another one.
Nice.
Oh my gosh.
Right? Very surprising when you sit and look at it. Now, there is an assumption being made here that if you're working, you can't study. So either you're working or you're studying. That could be the way it is in China. I don't know. When I went to school, as many of you, you're probably working while you go to school too. So this is one of my favorites. A little bit dated, although not so much really.
Don't know where Iraq is. Stupid.
Love that. Love that. Can't find Iraq on a map.
Oh, I love
We should
Can't
not
find
find a
it.
fight in countries if our citizens can't find where it's-
What's interesting? This was from 1994, 1995. The percentages aren't that far off today, as we just saw from Gallup. They're pretty much the same. It's been divisive. It remains to be divisive. It's happened, yeah.
Did they purposely take out a red stripe and add a, wait a minute.
There is one more white stripe or red stripe than red, but the white stars make up for it. That makes up the equal. Yeah, there's 13 stripes in the 13 original colonies, of which Delaware was the first. Just saying.
Oh, okay.
Just saying.
Is that why you're in Oregon now?
Just saying. No, Delaware sucks. That's why I'm in Oregon now.
Too many you out.
What's that? I voluntarily left. Didn't kick me out. My mom cried. Anyway, that one sucks. It's too dark. This one here, it is. It's just too dark for this room. This is an interesting one. This one makes you work for it. What are you looking at? Yeah, exactly. What is it? I like the ones that make you work.
First class, second class, third class.
Yeah. Crew, first class, second class, third class.
Plane crash.
Titanic.
It's the Titanic. It's the Titanic. It's a breakdown of the Titanic by the class of the person on board, the genders, and whether they lived or died.
Wow.
Now what I love about this, you don't see any numbers up there at all. So you don't know. There's roughly 2,200 people that were on board the Titanic. But you don't see that. What you see is basically percentages. So this is the total number of people on board the Titanic, up top there. I can't really point to it. So what percentage do you think are crew?
Huge.
Ish?
40?
40? Yeah, I'll go with 40. How about first class? 10? Second class, roughly 10% as well. So third class would be 30? Yeah, I'll buy that. I'll buy those numbers. So you got roughly those percentages. Then they break those groups down by gender. So the crew was predominantly male. Very, very few female crew. First class, yeah, split evenly-ish. Second class, a little more male than female. Third class, predominantly male, not so much female. So that's a breakdown percentage-wise again. And then last but not least, the live-die ratio. So let's go with female crew members. What happened to them? Yeah, it looks like a 2-to-1 maybe ratio, 2-to-1-ish. Maybe 3-to-1. It's kind of hard to tell with that small of a line. How about the guy crew members?
They died.
Almost a 90% chance of dying if you're a guy crew member. A few lived. Probably the ones that lived were the ones piling on lifeboats, I would imagine. The ones that got off the
getting
boat.
on the lifeboats.
Right. So that's the crew. How about first class? Let's go first class women. How do you feel if you're a first class woman?
Pretty safe.
Yeah,
You're feeling pretty safe. You're feeling pretty safe. There's the ones that died. That's, what was her name? There was that couple, the old couple. James Cameron loved this in the movie. The Strausses, I think. There's a great scene. It's more because they died, but the water's rushing into their bunkhouse, and the two of them are cuddling on the bed.
Yeah.
Cameron just shot it beautifully. But yeah, I think that's her. That's her right there. The rest of them lived. How about first class guys? Maybe like 2-to-1, 3-to-1, 2.5-to-1, somewhere in there, right? Second class. How about second class women? Ish. It's kind of the same as first class, not quite as exaggerated. Second class guys? A lot of them died, not a whole lot lived, right? How about third class women? Third class women are the only class where more died than lived, right? They're the only class where more died than lived, right? This guy's thicker than this guy. How about the guys? Now the guys in all classes more died than lived, so third class followed that trend. Cameron had a field day with this one too, if you remember. He showed them being locked down below decks, as the water rushed in. So Cameron, I have no idea if that actually happened, and I think a lot of the survivors' families objected to that. But he had a field day with these. No, he had a field day with these statistics. It could have just been a function of the time it took them to get up to the decks, since the water was coming up from below decks. So, but I love this because it makes you work for it. It makes you like look at what the hell am I looking at? And some people just click and change the channel. But at the same time, if you're interested enough to sit in there and look, oh, it's the Titanic. More reveals itself to you. Okay, here's a $100 bill. Yay. There's 100 of them. Yay. That's what $1 million looks like in $100 bills. Some of you may have seen this before. I pulled this off of a Google mashup.
Yeah, this is pretty ridiculous.
That's $1 million.
This,
Very small. Very small. Okay. This is $100 million. It's on a pallet, so you can move it around. And there's a 6-foot-tall dude for reference. Okay, if I want to look at $1 billion, what would that be?
100 of those.
It would be 10 of those, right? It would be 10 of those. That's 100 million, so 10 times would be 1 billion, 1,000 million. So there's $1 billion. Okay, now remember, friends, that's a million. That's a billion. The number that is being thrown around an awful lot in the news right now is $1 trillion. And the problem is, I've actually heard politicians say things like, I don't care if it takes $1 million or $1 billion or $1 trillion, solve the problem. Well, I care because that's $1 trillion. Now, please notice our little friend over there.
Oh.
See him over there?
Oh, wow. Double stack.
And they're double stacked.
how much is 16?
And they're, hang on, Chris. So that's $1 trillion. This was the debt in 2009. Which is, I believe, now at least 50% higher than it was in 2009.
Yeah.
So I care, Mr. Politician, if you spend $1 trillion versus $1 billion, because we're the ones paying the bill for that. So, but that's the problem with the word million, billion, trillion, quadrillion, quintillion. They roll off the tongue so easily.
We're never gonna
It's almost like $1 billion should have 1,000 more syllables to make the politicians say it. Okay, we have to spend, and then make them spend 31.7 years saying the damn word, honestly. So, anyway. Again, very powerful. A non-standard way of this is a Google mashup. Some Google user actually created this. It's beautiful. It's a beautiful, powerful way. Rather than just seeing the national debt is $16 trillion, boom, there it is. Ow, that hurts.
We're never
It's actually impossible for someone to visualize in their mind what $1 trillion really actually would look like.
It's too big.
Our brains.
It's too big. My son has a great book called How Big is a Million? We read it every week, and it talks about stacking pennies and how big $1 million stack would be, $1 billion stack, $1 trillion stack, going out to Saturn. I mean, it's impossible to, as you said, Raphael, it's impossible to visualize what that is. And he's like, oh yeah, Saturn. I'm like, you're so cute. What size?
What size building?
Oh, there is, Google that. There is, I've seen it. I didn't have it in here. There's an image that actually does that, where they have Empire State Building comparators and things like that, like a pebble versus the Empire State Building. It's out there, trust me, it's out there. Here's the last one I want to close with. This is my favorite, it's also very depressing, but it's my favorite. How many of you have seen this image before? You may have seen it in art history classes or just around. And I want you to focus on just that one part of it. I'm gonna zoom in. Just skull smoking, right? Skull smoking. I'm gonna focus. We're gonna zoom in. We're gonna keep zooming in. As you know, what often happens when you zoom in on a picture that pull up the internet is it gets pixelated. But as you start zooming in, you start realizing that the pixels are not really pixels. They're tops of cigarette boxes. Because what you're really looking at is a copy. This is the Van Gogh skull of cigarette painted back in 18-something, which I can't read. This is Chris Jordan, a Seattle-based artist. Phenomenal. I gave you a link to his site here. I've also got him linked in off the original page of the site. I highly encourage you to check out his stuff. That picture is made up of 200,000 packs of cigarettes. Look at that.
400,000.
Every 6 months, we lose 200,000 Americans due to cigarette smoking. Every 6 months. It amazes me when I hear people say, like, yeah, my uncle can run a 6-minute mile, and he smokes 2 packs a day. Yes, he's called an outlier. He's called an outlier. Or just a liar. Very nice. Touche, Tansy. Very nice. Glad that was on audio. But Chris Jordan has a whole series called Portraits of American Consumption. For example, he's got one that looks like what's that art form? Impressionistic. Female breasts. And when you zoom in on it, it's made up of Barbie dolls. And each Barbie doll stands for one breast augmentation done electively in the United States each year. So elective breast augmentations with Barbie dolls. He's got a whole series of this. One of my favorites and depressing ones. It's 5 huge orange rectangles. Each one's roughly the size of one of these boards. against the wall, and there's a picture of this old couple like staring at it like this. It's his parents at one of his art shows. And your big orange rectangles, you're like, oh, it's one of these modern art people with their big orange rectangles. And then you go in there, and it's little tiny prison uniforms stacked. And each prison uniform stands for one incarcerated American in whatever year he did it. Everything he does is like that. It's amazing stuff. It really is. I mean, I'm not paid by the guy to say this. It just is amazing. He did a TED Talk. If you guys have seen the TED videos, he does a 10-minute TED Talk that is to die for if you have 10 minutes to spare.
He would be on the piano.
Please, Princessa.
What's the homework?
Oh, hang tight. Yeah, we got to do the homework now because we had a question about that. Let's make sure we wrap up with that. So, I want to collect a little bit more data, and we'll play with this next. We're out of time now. We'll play with it next time. So, how many keys do we have with us right now? How many keys? How many have 0 keys with them? 0 keys, not 1 key. You got 8.
Bike block.
Block. Okay, so no 0. You have none. No keys. How many do you have 1 key with you today? You got any with bike lock? Yeah, you got 2. Okay, you got 1. 1, 2, 3. How about 2 keys with you today? 2 keys. 1, 2, 3, 4, 5, 6, 7, 8. I'll keep track of this. We'll bring it back on Monday. 3 keys with you today. 1, 2, 3, 4, 5, 6, 7, 7. 4 keys with you today. 1, 2, 3. 5 keys with you today.
I think you have too many keys.
6 keys with you today. Somebody had 21 in the last class.
Wow.
6 keys.
Must have been
Just 1. 7 keys. 1, 2, 8 keys. 9. Anybody above 9? What do we got, Mike?
16.
16.
Really have too many.
Beth has 11. There we go. Anybody else accounted for? Okay, fantastic. So, let's come full circle. Raphael asked a great question about how you deal with homework in here. So, right here it says, now homework for Intro to Province Stat. At some point, probably in the next half an hour, I'm going to dump all this video onto my computer, make the video, get it uploaded to YouTube. There'll be a link on the schedule page to that video. There'll also be a link to this PowerPoint. So you can download the PowerPoint and do with it as you will. There'll also be a reminder. Remember to bring homework questions for next time, and I'll link that back to the homework page. However, let's find that homework page together right now real quick.
There's 2 quizzes due next Wednesday.
That's next Wednesday, yes sir. I'll try to remind you that in class. Remember, they're optional though. Do it if you want to. I think you should. Those are good ones. So here's the page. Go to the course information. Go to the schedule page. Okay? Now all of that will be linked right here with this quiz here, but the homework sheet is here. There's the homework assignment for Monday. Knock this bad boy out. Do these guys from the book, these few extra problems down here, and then we'll discuss them first thing on Monday. Okay? And I'll have links to all this stuff on the schedule page in about half an hour.